Okay, for lesson 4 for unit 8, we're going to talk about the area between two curves. So it's just an extension of the ideas that we have, okay, about area. So we're going to talk about that and how we would do that, which will help you hopefully not accidentally mess up when you're just trying to find area under a curve, because it's going to help you make sure you realize we have to find out if it goes underneath or not. All right, so we're going to look at a situation, and there's two different ways that generally we do this, and that's with whether it's in terms of x or if it's in terms of y. And there's a couple of reasons we would choose one over the other. So basically, if the functions are already in terms of x, we would choose it that way, or if they're already in terms of y, we might choose that. And then we'll also see that sometimes one way or the other way is better because we'd have to do two integrals certain ways. Okay, so we're going to talk about that. So let me erase because I don't know why that's on there. So let me erase all that and let's go through this process. So we're supposed to graph these functions. So the first one is this parabola. And just to make sure you see why that's the graph, or if you need to draw it on your notes, of course we have negative, which means it's a parabola that opens down. The center is going to be at 2, 6, or the vertex, sorry, not the center. So we can see that on that graph there. It's at 2, 6. And then you just plug a couple of points in to the right and left of that vertex so that you can see some values. So if I'm choosing what I want to do, then I'm going to choose to plug something in for x that when I subtract 2 stays even, because I have to multiply by -1/2. So there's just some hints for how you can get some points. So if you need to put those graphs on there, and then of course the second one is a line, then you can pause the video and do that. So then the first thing says find the value, after we've drawn those, of the integral from 0 to 5 of f of x dx. So this is f of x. And we want to just simply find this value. What is the value when we do this integral? Okay, so you could multiply out that binomial, that x minus 2 squared, and make it x squared minus 4x plus 4, then take it times -1/2 and all of that. But don't forget that this is just a power, right? It's just something raised to a power, and the inside function, the derivative, is 1. So you really don't need u substitution. You could just raise the power, add 1 to the power, and divide by the power. So we're going to have -1/2, and then we're going to leave a little space. We're going to do x minus 2, and we're going to raise it to the third. Then we're going to divide by 3, so I'll just put times 1/3, and that one's done, because remember, du was just dx, so I didn't have to do anything. Then plus the integral of 6 is 6x, and I'm going from 0 to 5. So we're going to go ahead and do all of this work. Let me move this stuff out of the way. So let's go ahead and finish, because we need the practice. So it's -1/6 times 5 minus 2, which is 3 cubed, plus 6 times 5, which is 30. Minus parentheses -1/6 times -2 cubed plus 0. Okay, so remember always to plug in 0 and make sure that it's actually, if it's 0 or not, because it's not always. And a lot of times we want to just automatically say, oh, plugging in 0 doesn't do anything, but it does sometimes, so we need to practice that. So then what I'm going to do is I'm just going to simplify the fractions a little bit. And since this has a 6 on the bottom and this does, even though they can simplify a little bit, they're both over the same denominator at the moment. So I'm just going to go ahead and combine them. So I have -27 over 6. And then I have, and follow this, I have minus a negative, and then negative 2 cubed will also be negative. So that's also going to be negative. 2 cubed is 8. 8 times 1 is 1. So I'm going to have 8 sixths negative, and I have negative 27 sixths. So that's negative 35 sixths, and then plus 30. And 35 sixths can't reduce at all, so we just have to get a common denominator here. So 30 would be 180 over 6. 180 minus 135 is 145. So we end up with 145 over 6. Now, those are always good to practice, because remember, you're going to have to be able to do that. Okay. Now, we shade the region for what we just found in blue. Okay, so I'm going to take a highlighter. You can do it with your colored pencils. Just make sure you do it very lightly. So from 0 to 5, underneath the parabola would be this. And that whole thing is what I would get. Okay, if I were to if that's the answer that I just got, that's that area from 0 to 5 underneath that parabola. Okay, now it says draw the function 4 minus 1/2 x. That's of course just a line, so that's an easy one to draw. Of course you'll have a y-intercept of 4, slope of negative 1/2, so that should be really fast. So draw that segment, or that line. And then it says find the value if we integrate that one. So now we're just going to integrate g. So I'm going to integrate from 0 to 5 of 4 minus 1/2 x dx. So I'm going to get 4x minus x squared over 4, and I'm going from 0 to 5. So that's 20 minus 25 fourths minus parentheses 0 minus 0, or just at least write minus and then 0 to make sure you get that right. So this one will be a little bit easier. 20 is 80 fourths. 80 fourths minus 25 fourths would be 55 fourths. Okay, then it says shade that region green. So that's underneath just the line that we've drawn from 0 to 5. So let me get a highlighter that's green here. So that is this part right here. And that answer, 55 fourths, is that area right there, okay, of that shape. Now, what I'm interested in on part G, it says, how would I find the area of that region that lies between the two? So how would I find, and I'm just going to use purple just to make it clear, so how would I find this area? I guess it's not going to look very purple, but how would I find this? Okay, how would I find just that area? Well, clearly I would do the area, this was blue, right? This was the area underneath the parabola, right? So that was one area. And then this area was the area underneath the line, and I want the part that I have shaded kind of purple there, so I simply would subtract. I would just subtract the bottom one from the whole thing, and then that would leave me just that purple part, okay? Well, since both of them are being integrated in the same place, then what I can actually do is just, what I can actually do, the general way to do it would simply be to integrate from 0 to 5 and just do f of x minus g of x. Because remember, if you're adding or subtracting, you can just put them as one separate integral or one single integral if they're doing the same thing. Okay? So our general formula, which for some reason there's no general formula on here, but basically this is on the next page where it talks about that, the general approach. But you can basically write down the general approach is going to be to integrate from a to b of f of x minus g of x dx. That's how I find the area between two curves. And you can also just say, I will say this all the time, top minus bottom. So most important thing for you to know is which one's on top, which one's on bottom. So usually the first thing we're going to do is find out where they intersect. Now this one is telling me specifically to go from 0 to 5. But if you look back at our drawing, you can see that where they intersect is 0 and 5, which is the reason that we did that. Because right here is where both of them have x is 5, and then where x is 0, that's where they actually intersect. So normally we would have to find where they intersect. We would just be finding the area between. This was just to give you the idea of how all of that worked. So if I was going to write all of this out, then what I would do is to find the area, and we usually use a capital A, 0 to 5, f of x was the negative 1/2 x minus 2 squared plus 6. And then I'm going to subtract parentheses 4 minus x over 2, and then dx. And really the whole thing kind of in brackets here, whole thing dx. Okay? So don't forget minus parentheses, okay? Because you're subtracting a function, and if it has more than one term. Now, if I was doing this problem, so the last problem, we just integrated separately and all that. But here, what we want to learn is, I want to simplify this. I certainly don't want to do all of those integrals all separate, all those different terms and everything. I want to simplify what's inside there to make it much easier for me to integrate. Now, you can go over to the side and do all of the algebra and then just come back and write it. For this one today, I'm just going to go ahead and do it right here. So I'm going to have, so remember we said if you do x minus 2 whole thing squared, you're going to get x squared minus 4x plus 4. So I'm just going to remember that and take it times negative 1/2 each time. So I got x squared times negative 1/2. So that's going to be negative 1/2 x squared. And then the middle term is minus 4x times a negative 1/2. So that's plus 2x. Negative 2 times negative 2 is 4 times negative 1/2 minus 2. Then I still have the plus 6. And then I'm going to have minus 4 plus 1/2 x. Okay, that's what's left on that part over there. Now, I'm not done. I'm going to go ahead and combine any like terms to make it easier, and then I'll integrate it, and life will be much easier. So I'm still not integrating it yet. So I still write 0 to 5. I have negative x squared over 2 because there are no other x squared terms. But x terms, I have a 1/2 x and a 2x. So that's going to be 2x would be 4 over 2 plus 1 over 2. So that would be 5 over 2x. And then I have minus 2 plus 6 minus 4, which is 0. So obviously, this is much easier to integrate than it would be to do the original problem. So really important to remember, always do the algebraic simplification when you have many, many terms in there. So always simplify it and then go through the process, okay, and do this. So now we're going to go ahead and integrate it. So we're going to get negative x cubed over 6, because I raised by 1, divide by 3. So that's going to give me that. Plus 5x squared, again, over 2, but there's already a 2 there, so that's over 4. And I'm going from 0 to 5. And so when I plug in, I'm going to plug in the 5, and I get negative 125 over 6 plus 25 times 5 is 125 over 4 minus parentheses 0. Again, always check when you have to plug in 0. So to get a common denominator here, this is the thing that I want you to practice, because again, for non-calculator questions, obviously calculator question, you would have just done with the first step. You just put that whole thing in the calculator. I wouldn't have even done any simplification. But obviously a lot of problems are on non-calculator parts, so we need to know how to do it. So the easiest thing to realize, I realize what the common denominator is, it's 12, so I just write times 2 times 2 times 3 times 3. Instead of rewriting them with 12s, that's everything I need to get this answer in one step. It's going to be something over 12. I'm going to have, from this first part, negative 250 plus 375, so that's going to be 125 over 12. Worst case scenario is possibly that fraction then reduces afterwards. But even on multiple choice, that's where I would stop, and then I'd go start checking my answers, and then if they didn't have that denominator, then I'd look to see if I could reduce. So really good problem for you to take some time and go back and look at this problem, because it's not really difficult. Nothing in here was hard, but it's some good strategies for doing integration, because some of you definitely spend maybe too much time on some things that you need to, get some quicker methods to be more efficient to help you make less mistakes. Now, this is also important. Area, you integrate top minus bottom. Okay, super easy. Top minus bottom, and the A to B is just where they intersect. Okay. All right. Now, if my functions look like this, okay? So the part that I want to actually integrate, so I'm just going to use a highlighter and I'm just going to highlight the area, is I'm trying to find, I want to find the area that's bounded by, so this is very common that they're going to say bounded by graphs of. So that means I would need to draw those two graphs, or they would already have a drawing. So what I'm wanting is this area right here that's bounded by these two graphs. Okay, now here's something that I'm going to suggest that you do, because this is going to help us a lot when we get ready to do volumes in a next section. Okay, so we're going to draw what I call a representative rectangle. This rectangle represents the height going from top to bottom, or in this case, right or right to left. Okay, so if it's turned sideways, and that's the way I want to integrate it, in terms of y, it's just right to left. So I want to show you something, and don't necessarily write this, just pay attention, and then I'm going to delete it because it's going to be y. I'm going to do something different. If I wanted to do this in terms of x, okay, so I decided to do it in terms of x. You got to think about when we learned integration, right, and we had a formula, we had something, and we wanted to find the area or integrate from here to here. Well, what did we do? Well, we drew rectangles, right? We drew all these rectangles, whether they were left or right or whatever, and then we added them all up, and then we let them go to infinity, etc. Okay, so that's how we did it. So what I want you to draw is what I would call a little representative rectangle, okay? So if I'm going to do this one, if I draw a rectangle and I want to do top minus bottom, well, right here, the top graph is definitely the line, and the bottom is that parabola, that sideways parabola. But what I have to pay attention to is, would every rectangle that I drew between those two curves, would all of them go from the line down to the parabola? And the answer to that is definitely no. Because what if I draw a rectangle over here? Well, that rectangle going from top to bottom is going from parabola to parabola. So if I were to do this graph in terms of x, so I wanted to do top minus bottom, I would have to do the extra work of splitting it. Okay? And this part I would do integral from, so it looks like they intersect at -1 and 2, so I would integrate -1 to 2, line minus parabola. Then I would have to do another integral from 2 to 3, that is parabola minus parabola, okay, in order to get that answer, and I'd have to add them together. So obviously that's not the preferred thing to do, because that's going to take me a long time. So I'm actually just going to get rid of all of that stuff I just wrote, only because I want to show you, I wanted to show you my thought process, so that's a way I could do it. But then I look at it and say, okay, but what if I draw a rectangle right and left? So now I would be going from the parabola on the right to the line on the left. Now, every rectangle that you draw inside this region that I painted yellow, obviously all horizontal rectangles, wouldn't all of them, no matter where you drew them, all of them would go from the parabola on the right to the line on the left. Well, the advantage to that is now I only need one integral. Okay, so that's a reason to do it in terms of y. Now, these particular equations were actually already written in terms of y, but that doesn't mean that I wouldn't want to solve them so it works out actually easier for me, okay? But that's what I want you to do, is draw a rectangle and think to yourself, everywhere I draw a rectangle, am I always going to go from this curve to this curve, which I would not do if I drew vertical ones, right? So horizontal makes more sense. Then what I think of is when I looked at these rectangles, right? When I did my area and I added up, remember that the width was delta x for all of these rectangles. Well, that's what became dx, and that's how I know my entire function has to be in terms of x. If I draw my rectangles this direction, so they're horizontal, then that means the width of the rectangles is delta y, which means that this is going to become the dy, which means I want everything in the entire problem in terms of y. Okay? So this is that importance that I told you before about why we need to have the limits of integration and the dy has to be written and so on. Okay? So basically, if it is right and left, like this way, if I have a horizontal representative rectangle, okay, so that's the one that represents this situation best, then I'm going to integrate, my generic formula will be integrate from C to D, and we just use C and D because A and B are usually our right, or on the x-axis, so this would be my y values. And I'm going to do, instead of f of x and g of x, I will have, and we can write it different ways. Sometimes we say use different letters, but it doesn't really matter. I can just say f of y minus g of y. Sometimes we'll say, you know, different letters. It doesn't really matter. But the key here is limits of integration, and this are y. So, and everything else is. So it's going to be right minus left, okay? And then everything's in terms of y. So that rectangle actually does make some difference, okay? So you'll kind of understand if you practice that way, okay? So let me extend the page here so I can go ahead and do the problem. So for this example, we are integrating, so we need to look at the graph and see where the y values are for our limits of integration. So that would be from -2 to 1. Okay, so that's where we integrate. So I'm going to integrate from -2 to 1. And then the function on the right is 3 minus y squared, because it's a sideways parabola. So we will have right 3 minus y squared minus left, which is y plus 1. And you can't just, and that's being parentheses, of course, because you're subtracting the whole thing. And you can't just like take the x's out and make them y's. If the functions hadn't been solved for y like that, we would have had to solve them for y in order to do that. So this is what we're going to integrate. So again, we're going to practice this. So we're going to first, before we do anything, we're going to combine any like terms and simplify it so it's much easier to do. So I only have minus y squared. I only have a minus y. There's no other y terms. And then don't forget it's minus 1 here, and I have a 3. So it's 3 minus 1, which is 2. So that's what that would simplify to. Now I can just do all my integration, and remember, it makes no difference what order you put it in. So if you like to put that subtractions last and the 2 first, it makes no difference. That's irrelevant as long as the signs are correct with the numbers. Okay, so I get minus y cubed over 3 minus y squared over 2 plus 2y. That should be second nature now and really fast. And I'm going from -2 to 1. So first time through, don't do a lot of simplifying, remember, because after I plug it all in, then I'll combine everything that has the same denominators, and then I'll get a common denominator. So I just plug in. So -1/3 minus 1/2 plus 2 minus parentheses. Now plug in -2. So -2 cubed is -8, but then there's a negative in front. So that's 8y over 3. And then negative 2 squared is 4. So that's 4 over 2, which is 2. So this will be minus 2. And then plus, actually that one will be minus, because 2 times negative 2 is minus 4. Now what I would do, oh, not 8y over 3, sorry, not y, 8 over 3, because I plugged negative 2 in. So this first term, I plugged in negative 2. So that's negative 8 times a negative 8/3. Now what I will do is I will combine things together that can go together. Always do that first. Never, ever, ever get a big common denominator here. Just combine. So I have negative 1/3 minus 8/3. So that's negative 9/3, which is actually negative 3. I have a negative 1/2. Nothing else ended up with a half in it. Then I have 2 minus negative 2. So that's 4 minus negative 4, which would be plus 4. So that's plus 8. So negative 3 plus 8 is 5. So you have 5 minus a half. That's 10 halves minus 1 half, 9 halves. Please, 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 please practice on these problems doing it this way. Combine things that have the same denominators first. Get all your whole numbers added together. So much easier, okay? So much easier than trying to make everything over 6 and doing all of that work, okay? So you'll be much less likely to make a mistake. Okay, so what that means is the area of that yellow portion is 9 halves. Okay, so the area between those two things. Okay, so now let's talk about really what the more common problem is. I've got two graphs and somebody says you need to find the area between these two graphs. Well, sometimes you'll have a picture, sometimes you won't. Sometimes you have a calculator, so you'll have to, first thing I would do, anytime anybody asks me about area, I'd graph it on the calculator if it was a calculator problem. If they just give me a picture of the graphs, then I'm just going to look at them. Well, here's where that representative rectangle is such a good idea, because I have two functions here. So the cubic function is well, I'm just gonna use red and show the cubic. So this is the cubic function, obviously. So this one is f of x, and then g of x, let me use green. So this is the quadratic, so obviously this is the parabola, so that has to be g of x, okay? Well, if I want to find the area, and even just doing that, do you see how much hopefully more clear it is that you can't just do one integral here? Because if I were to shade or just draw, let's just draw my rectangles, my representative rectangles here. In this part, it's going to be the green curve minus the red curve, okay, in between there. And every rectangle I draw would always go from the green to the red until I get right here where we have an intersection. And now it switches, and now it's red curve minus green. Okay, so that means I'm going to have to do two separate integrals. So what I need to do is find out where they intersect. Now, if it's a calculator question, this is a really easy question to do, but often they're not going to be calculator questions, okay? So if I want to find the intersection of the two curves, the intersection, of course, means where are they the same? Okay, so I would do this. Now, if I'm on a calculator and I've already graphed the two functions so I can see what I need to do, of course, I can just use the intersection tool, or I can trace and find those intersections, okay? But by graphing it, again, it makes it clear to me that I'm going to have to separate this into two parts. But on a non-calculator question where I just have a picture of the graph, I'm going to have to find the intersection myself. So we're going to combine everything together and move it to one side because we want to set this equal to 0. So I'm going to move everything to the right so that my largest power becomes positive. So my negative 2x cubed move to the right, and then I'll have x squared minus x squared, so those will actually go away. And then I'll have 14x that I have to subtract to move it over, so this becomes minus 18x. And of course I set that equal to 0. we solve all of these questions, of course, by factoring. So I factor out 2x. So I have x squared minus 9. And then my answers then for where it equals 0 is going to be where x equals 0, that's from here, x equals 3, x equals negative 3, right? Because there's two answers to that, 3 and negative 3. So that tells me that I need to integrate from negative 3 to 0 to get what we can call area 1. And then I can integrate from 0 to positive 3 to get what we can call area 2. Then adding both of those up, that will give me the answer that I need here. Now, all you have to do to answer the question is you can simply say area equals the integral from negative 3 to 0 of g of x minus f of x, because looking at your picture, when you're at negative 3 to 0, then the parabola is on top and the cubic's on the bottom. So that's g minus f. And then plus integrating from 0 to 3 of f of x minus g of x. Now, if this is a calculator question, this is all you would have to write. You would already have stored your functions because you graphed them so that you could see your intersections. So they're going to be called like F1 and F2 or whatever. So you would simply, this is what you need to write to show your work, and then you would just do this whole thing in your calculator. Now, I'm actually going to skip the steps of actually doing this area because I want you to practice it. Now, I am going to write down what we get. So we have g of x minus f of x. So since they're written right here, we can pretty much do that pretty easily. It's g of x minus f of x. So you're going to have x squared, and then you'll have minus an x squared, so that'll be gone. You'll have negative 4x minus 14x, so you'll have a negative 18x minus negative 2/3. So this will be negative 18x minus a negative 2/3, so that's plus 2x cubed. Or minus 2x cubed, but it's minus a negative. So that means that this one will be the same thing, but with opposite signs, right? Because it's just you're subtracting in the other order. So this will be 18x minus 2x cubed dx. So I'm going to leave that for you, and I strongly suggest that you hit pause and that you do these integrals and then combine terms and practice all that work. Because again, if it was a calculator problem, and we will do some in class, that is a whole different thing. But if it's not a calculator problem and it's on free response, you'll have to do all of this work. So I'm just going to tell you that when you get done with all of that, you're supposed to get an answer of 81. So strongly suggest you pause and do that now, or you do it later, but leave yourself a bunch of room to do those integrals and practice. Okay? So the last examples we will do in class, so we will go ahead and cover those examples that are on here, but I'm not going to do them on the video, so this is enough notes, and then you need to actually practice that. And then we'll finish the rest in class. You know.